Yes, dx dt greater than 0 is a reason for A. So for A, 3 points, 1 for moving to the right with the reason that dx dt is positive. 1 point for looking at dy dt over dx dt, or like making an attempt to do that, and 1 point for finding the actual slope at t equals 2, which was 3.055. We did all that last time. We just didn't talk about the point. And then for part B, last time, did we find that x coordinate? I think we did, right? We did the integral of it and did all that. Yeah, came out to be 1.253. That was worth 2 points, 1 for the integral itself and 1 for the answer. So remembering that you needed to use the initial condition. And then for part C, we were looking, and so we didn't do part C last time. We did some of it. Okay. Well, we'll just start part C. So for part C, we were finding the speed of the particle at t equals 4. Oh yeah, you were all arguing and I couldn't pull up the scoring guidelines. Okay. Yeah, so we wrote out for part C that the speed was the square root of our dx dt at, what was it, 4 squared, and our dy dt at 4 also squared. And that should have come out to be, for all of you guys as arguing last time, it should have been 0.575. So whoever got that, you were right. Whoever got something else, you were wrong. Okay. Yeah, that's what it should have been. 1 point for that. And then they asked you to find the acceleration vector, which meant you needed to take the derivatives of each of those and evaluate them at, what was it, t equals 4 also, I assume. So your acceleration vector ended up, and just have your calculator take the derivative of dx dt at 4 and the derivative of dy dt at 4. Came out to be negative 0.041 and 0.989. And that was also worth 1 point. Yes, 2 points for part C. Yes, Kevin, you can use this time to, and I quote, review Sacco's horrible comp sci notes. Sure. Just putting that in quotations, that I'm not the one that said that. He already hates me enough, so. Kevin, as far as I'm concerned, you can do whatever you want with the rest of the school year, except that you need to take the quizzes on Friday. Same with you, Ryan, since you took the AP test already. Show up to Zoom and just do whatever you feel like doing. What? Listen, okay. Be quiet, Derek. All right. The Friday quiz, I don't know. What's the Friday quiz going to be on? Particle motion problems? Yeah. How about that? Particle motion problems. Sure, why not? All right, part D. Quiet, Derek. Or else I'm going to tell them that you're not wearing your mask properly. And then you'll have to get sent home. Just kidding. Haha, just kidding. Okay. All right, we want to find the distance traveled by the particle from t equals 2 to t equals 4. So that's just the integral of the speed. I'm not going to write it all the way out, but you would write it all the way out from 2 to 4. So just the integral of the square root of dx dt squared plus dy dt squared. And that came out to be 0.651, and that was worth 2 points. 1 for the integral, 1 for the answer. Everybody good there with that particle question? Yes? Any questions on that one that we were finishing up? See, people keep showing up late. I keep thinking, oh, it must be Gina showing up to the Zoom now finally. It never is. Weird. Okay. All right, this was the next one, yeah? And you guys worked on this one on your own and it went great? Yeah. Wonderful. Find the speed of the particle at t equals 3. So the speed of the particle at t equals 3 should just be the square root of dx dt squared at 3, which is I think it's just 13. If I plug in 3 to that, that's just 13. Yeah. 169. And then this one is dy dt, so sine of, what was it, 3, so sine of 9 squared, so sine squared of 9. And then you square root. And that came out to be, what did you say, 13 point? I'm sorry, the correct answer is 13.006. Although it also says or 13.007. So 13.006 or 13.007 is B. Everybody good there with A? So the first part of A has 1 point for the speed. And then find the acceleration vector. So the derivative of 4t plus 1 is just 4. And when t is 3, 4 is still 4. And then this one, you just have your calculator evaluate the derivative of sine of t squared at 3. And that came out to be negative 5.467. Everybody good with that? 1 point for the acceleration vector. Any issues there? All right, part B, find the slope of the line tangent to the path of the particle at t equals 3. So that ought to just be dy dx, which ought to just be dy dt over dx dt, which ought to just be, what, 13 over sine of 9, which came out to be what? Oh, I wrote them backwards. I wrote them backwards, didn't I? Did I see backward? Where? Oh, backward, back, back. What does that come out to be? 0.031? Sorry, the answer is 0.031. It says or 0.032. And that was worth 1 point. Everyone good there? No questions, no issues on part B. People at home in the Zoom, are you good?
Good.
Good Zoom. All right. Part C, position of the particle at t equals 3. So we need to find the x coordinate and the y coordinate. So we got to integrate 4t plus 1 from 0 to 3. And what was the initial position at t equals 0 of the x, or the x coordinate of the position? It was just 0, right? So we don't really need to add anything. And then the y coordinate initially at 0 was, or was it at 0? Yeah, 0 was a -4, so -4 plus the integral from 0 to 3. What was the other one? Sine of t squared, right? And whatever that comes out to be, it looks like that comes out to be 21 and -3.226. That was worth 4 points. 1 for integral, 1 for integral, 1 for x coordinate, 1 for y coordinate. Super generous. Yeah. Easy. Yeah. I don't know how they decide how much everything's worth, but yes, you can. Yeah. Derek was asking if you can just write dx dt and dy dt inside the integrals, and yes, that is totally fine. Just if you do that, make sure you write, like if you're going to write it, make sure you write dx dt dt, right? Because the dx dt is, that dt is not part of the, yeah, you understand? Cool. All right, part D. Oh, I thought it'd be great on your quizzes. The D made me think about your quizzes. Isn't that sad? All right. Find the total distance traveled by the particle from t equals 0 to t equals 3. All right. Well, 0 to 3, integral of the speed. These should be pretty easy. We should be like pretty used to these by now. Dx dt squared plus dy dt squared. And that came out to be 21.091. 1 point for the integral, 1 point for the answer. Any questions there? And then I asked you guys to do one more, sorry. 2 more? Oh my gosh, that's a lot of problems for us to go through here. We should just move on to some other types too. Yeah. Yeah, I mean, we should go over them. All right. Part A. I feel like I should probably go over them still. You guys all feeling like you're pretty good with these though? Cool. You guys were also responsive and talkative when we were talking about Ryan and Gina on their.
Yeah, I feel amazing. I feel wonderful.
I suppose, yeah. All right, well, we're going to do this. All right, from 0 to 1.5, find all values of t at which the line tangent to the path of the particle is vertical. So if it's going to be vertical, that means that what? The y dx needs to be undefined, which means that d dx dt needs to equal 0 with dy dt not equaling 0, right? Because that's going to be indeterminate, which isn't going to give us a vertical tangent line. So we need dx dt to be 0 if dy dt to not be 0. So when is dx dt 0? Well, your calculator will tell you that dx dt equals 0 at t is, and then I'll have 1.253. Do people agree with that? Yes, no, maybe? One second, I'm trying to find this one, just so I have it. I'll actually have it. Was this 2010? No, this one. Okay, yeah. So sorry, what did you get? 1.253? Yeah, okay. And 1.144. So you got 2 values. You guys all get 2 values except for Noah? Did you get 2 values there? Oh, you didn't even do it. Perfect. Yeah, you're right. So the scoring guidelines say sets dx dy equal to 0, but that, I mean, this would give you full points also. Yeah. Yeah. It's just like flipping it around to make it equal. Yeah. That's what we've done. Correct. It specifically says in the scoring guidelines, people here are asking me questions. It says it's vertical when x prime equals 0 and y prime does not equal 0. And then they just put some values. And they wrote sets dx dy equal to 0 as like a thing, but well, you may have. So did you guys find 2 or no? Did everybody else at home find 2? Cool. Great. Did you guys even do this? Are any of you even listening?
I only got 1, but I think that's wrong.
You only got 1? Yeah, I mean, I don't know. There's the graph. So definitely, I mean, there's definitely 2. Yeah, so recommendation for you. You guys, did I share? No, I didn't share this. Yeah. So if you, And you can definitely see that there's definitely two of them, right? My recommendation is if they, if they give you a specific interval, like 0 to 1.5, change your x values to 0 to 1.5 so that it spaces it out more. Like on your calculator, like when you're in the graphic window, you know how to change the window settings. Yeah, so just change the x min to 0, the x max to 1.5. And then you probably should be able to see then that it's crossing through. If you still can't, like if you're still not sure, just zoom in on that little part or change the y values because you can tell that it's very close to the x-axis there. So just change the y values to only go from -1 to 1, and then you'll be able to see really obviously. Welcome to class, Gina. Glad you made it home safely. Welcome to class, Gina. Welcome to class, Gina. Welcome to class, Gina. Welcome to class, Gina. She's there, just not responding. Welcome to class, Gina.
Thank you. I'm sorry.
Are you sorry for not responding or for being
Both.
30 minutes late?
I'm so sorry.
At least we've got a recording of this now, so when your parents ask why you were 30 minutes late to class, it'll be proof that it happened. All right. Yeah. Explain why you were late, Gina. Just for everybody's sake. I'm just kidding. All right, part B.
Oh my.
Having too much fun. I gotta stop. Yeah, we gotta do class. All right, part B. Write an equation of the line tangent to the path of the particle at t equals 1. So we need to find the slope at 1. Slope at 1 should be dy dt over dx dt. So that'll be 1 plus, well, we'll just say dy dx at 1. And what does that come out to be? The slope is 0.863. That's not an 8. 0.863447. Everybody good with that? That was worth a point. And then x of 1, we need x of 1 and y of 1. Right? And so do we have those already or no? They didn't give us those, did they? They just gave us positions at 0. So we'll have to integrate to find those. So we'll find x of 1 ought to be the position at 0, which is -2, plus the integral from 0 to 1 of dx dt. And y of 1, the value of y, our other point should be, what was that, 3? 3 plus the integral from 0 to 1 of dy dt. And the x value came out to be what? 9.3146695. And the y value came out to be 4.620537. Okay, that's fine. I mean, you have to on the test. Find the values? Yeah, I mean, it says write an equation of the line. They want numeric things, right? They want your answer to be y minus 4.621 equals 863 times x minus 9.315. They want that answer. Yeah. Sorry, make sure you do that. 4 points for that one. 1 point for the slope, 1 point for this x coordinate, 1 point for the y coordinate, 1 point for the equation. Part A was 2 points. One for, it says setting dx dy equals 0, but really this is 1 and this is 1 for the two values. So you would have got 1 point since you only got one of the values. Yeah. Everybody good with part B there? Wonderful. All right, part C. Maybe. Not writing. Part C, find the speed at t equals 1. So once again, our speed ought to just be dx dt squared plus dy dt squared, square rooted, at t equals 1. And what did that come out to be? 4.105? That was worth 1 point. And then for part D, what did it ask? The acceleration vector, I think? Yeah, the acceleration vector. So just evaluate x double prime at 1 and y double prime at 1. So the derivative of dx dt and the derivative of dy dt both at 1, which came out to be negative 28.425 and 2.161. And that was worth 2 points, 1 for each coordinate. Any questions there on that one? Feeling pretty good about particle motion problems on the AP test? Should be pretty straightforward.
Yeah.
This is the last one I asked you guys to do. Do we need to go over this one? What? We'll just go through it all. It's fine. All right. So for part A, find the speed. Okay. I think we know how to find the speed. How do we find the speed? Same thing. Square root of dx dt squared plus dy dt squared, which gives us, let's see here. So we have to find our derivative of x. So this is a dx dt is 2t minus 4. And so then we'll just evaluate all of that at t equals 3. And that comes out to be 2.828. Everybody good with that? 1 point. Part B, find the total distance traveled. That'll be the integral from 0 to 4 of that speed, right? And that should come out to be 11.587. It does say or 11.588 on the scoring guidelines. So I guess that's okay. And that was worth 2 points, 1 for the integral setup and 1 for the answer. Everybody good with A and B? All right. Part C says find the time between 0 and 4 where the tangent to the path of the particle is horizontal. Is the particle moving left or right? At that time, give a reason. So first off, the tangent should be horizontal if the numerator of the derivative is 0, which would be your dy dt is equal to 0. So you just need to, for part C, set t e to the t minus 3. Minus 1, 1 equal to 0. And what do you get? 2.207. Perfect. It says 207 or 2.208 on the scoring. Everybody good with that? And then is it moving left or right? How do we determine if it's moving left or right at that time? dx dt at t equals 2.207 or 2.208 comes out to be, it doesn't actually say, but it says it comes out to be positive, greater than 0. So we would say it's moving to the right. Everybody good with that? And you just use your calculator to find that value. Well, I guess it was, no, the dx dt was like a pretty simple function, right? It's 2t minus 4. Pretty obvious that it's greater than 0. And that was worth 3 points. 1 point for this, 1 point for this, and 1 point for this. Good? Okay. And the last part here, part D, oh, it has 3 different parts. So there's a point with an x-coordinate of 5 through which the particle passes twice. Okay? So find each of the following, the 2 values of t when that occurs. Okay, so how do we figure out when the particle has an x-coordinate of 5? Set t squared minus 4t, was it plus 8, equal to 5? And solve. This becomes what? T squared minus 4t plus 3, so t minus 3, t minus 1, t equals 1, t equals 3 for part 1. That was worth 1 point. Okay. Right. The second part of part D says the slope of the line is tangent to the particle's path at that point. We want to find dy dx at those t values. So dy dx at t equals 1, that should have come out to be 0.432. Remember, it's just dy dt over dx dt. And then dy dx at t equals 3 came out to be 1. Everybody good with that? That was worth 1 point. And then the last part, the third piece of it says the y-coordinate at that point, given y of 2 is equal to 3 plus 1 over e. So we want to find the y-coordinate of the point when x is 5, which happened at, like we said, t equals whatever they were, t equals 1 and t equals 3. So how are we going to do that? We're going to need to integrate what? Sure, 2 to 3, that's fine. We'll integrate from 2 to 3. Of our dy dt function. What was it? 3 plus 1 over e was the initial condition. Cool. So integral 2 to 3 dy dt plus 3 plus 1 over e. And that came out to be what? 4? Yeah, that's what it says, 4. And that was worth a point. Good or no? Any questions on that or any of the other particle motion problems that we have done? Or haven't done, I guess? Everyone's good? Doesn't matter if I pick 3 or 1. Should come out the same. Yeah, I mean, you're using your calculator, so it's not. I mean, you could use your calculator if you wanted. I imagine you did based on the nature of that function. I don't remember what the function was, but I know it was not. Not that's hard to integrate, but. Anybody else? Any other questions? All right.